Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket One Day, we're going to talk about what's next in space. So let's dive deep into it. Now, the reason we are entering this era where we have to actually ask what the heck we're going to do is simply because rockets are finally reaching the new era. Basically, we have crossed the Morse code, now we are in 5G. So things have changed significantly, meaning before this era, every time you wanted to think about any mission, any sort of system, any constellation, the only thing you had to think about is like, okay, which rocket? There was nothing other than that. It's like, okay, I'm going to build this telescope. Trust me, when you are designing that telescope, that's the time when you sit down and figure out which rocket you're going to, and can you afford that rocket or not. So it was a very different market, so to say, meaning there was no scenario where it's like, oh, I'm going to make this thing, it will be reasonably sized, and tada, see, we have options. But that is possible now. So we have reached a point where rockets are no longer the bottleneck. And all this started with a single rocket, which is F9, Falcon 9, and that was the first. And we have reaching a point where more and more rockets are coming online or in the drawing board. So sooner or later, basically, let's just say by 2035, rocket should not be an issue. Basically, it should be like take it and go. Take it and go. You could have multiple options. You'll have Falcon 9, you have Starship, you may have Stork, you may have Neutron, you may have New Glenn, whatever have you. So there should be more than enough option that any sort of bottleneck is alleviated, not only in size, volume, as in like size and weight, and in cadence also, meaning if you're like, hey, I want this small puppy going right now, okay, call up someone else. Oh, you have this, or call up someone else. There should be more than enough supplies of rockets that should not be an issue. And properly hoping that by 2035 Leo would be routine, meaning it would be boring. Oh, you went to Earth orbit, it should be boring, like that. That's how good things are, meaning if airlines are good, you don't want to hear about it, right? You do not want to hear it in news. That's not a good thing. So fundamentally it should be boring and routine, low cost, and risk should be very minimal, low cost and low risk. Plus we should reach a point where deep space should be possible. Right now, deep space is like very rarely possible, so to say, where we are just like throwing things and waiting for freaking 6-7 years or sometimes 10 years to get to somewhere. So that's not a true way of exploring, but we have certain things in plan, in construction, that should allow to remove that bottleneck also. Again, we were not thinking about that because rocket was the limit. That's no longer the case. And a lot more people will get access to space, and that could result in amazing things that we have not thought about. And here's the it's not limited only to travel agents and all that. The fact that now you can have college students actually making something and actually sending it to space, that was unheard of with reasonable cost. Now it's like, okay, if your country is wise enough, it will have a space program. If it has good enough space program, it will have cheap enough rocket. If it has cheap enough rocket, take it and go. Take it and go. So that is something that we can look forward to, meaning by 2035, rocket should be out of discussion, where it's like, yeah, we good, we got this, we done, boring, normal. Now, what comes after rocket? Well, the first milestone we must achieve is space station, because right now you have to understand ISS has expired, and fundamentally you have to understand ISS was a casualty of space shuttle, because when space shuttle was being designed, the target point was 2 times a month. That's what they were aiming for. It was supposed to be quote-unquote bus to low Earth orbit. Yeah, that did not turn out. They were having hard time even doing once a month, let alone like they were only managing 2 launches per year. That was the best case scenario. So ISS, the construction period like slowly got stretched. That's why I said rocket was always the weak link. It got stretched so much. It's like the actual original expiry date when they built it, like how long this could last. Yeah, that has come and went long ago, and we have to keep stretching because other things are not ready. So that's a very significant issue. So we have to, and again, if this puppy is still there, as in like not as a museum, as in like somebody actually living in it, yeah, we messed up. And you may like, okay, what's the danger here? ISS is made out of aluminum. Aluminum is not like steel. Steel does have this one benefit where it's like, if you're not stressing it beyond its point, it does not care. It's like, you can keep hitting it like as many times as you want. Aluminum is not like that. It fatigues. So aluminum's, that penalty is hurting it, meaning every time you're going docking to it, it is causing a bit of stress. Now, all of those things, firing rockets, people moving about, things adding, detaching, all of that, that's minor issue. The major issue is getting deep fried and deep frozen every day multiple times a day. So when it's on the sun side, sun is like GG, super heated, and the moment it goes the shadow side is like super cooled. So that fatigues it too much. Not only aluminum is a bad material for that stress cycling, the fact it has happening so much. The orbit is not sun synchronous. I think we should literally put something in sun synchronous as long as we can have enough radiation shielding. If we can do that, we should put in sun synchronous, so it's always in the sun. So it's not like hot or cold. It's like hot, done, good, go home. So fundamentally, that fatigues the craft. So that's why a space station is not something where you can just like put it and forget it, unless it's made out of like steel and it's like designed to handle that sort of expansion contraction for centuries. So that's the reason why ISS has to be retired. Like my hope dream would be you put it in much higher orbit and like safeguard it. It would be perfect museum piece. That's the idea with ISS, and nation states have to take a step back. Meaning right now, if I talk about space, the only thing I can talk about is China or USA. That was good. That got us so far, but we have to jump into private enterprise now. So at this point in time, we're supposed to dump in private money and supposed to get profit. Once we have that, that would be the next step of growth, because once the first time somebody makes their money back, I can guarantee you money will start flowing in. Right now the money is flowing, it's a few $1,000,000 per day, then a few $1 billion per day kind of thing. Again, sector wise, not like one company wise, sector wise. So we need, once the profit starts to come in, once somebody proves the idea that it makes money, problem solved. And what do we need in next ISS? Well, it has to be bigger. Duh. Now, another aspect of it, it was never, space shuttle was not really limited by the tonnage. Like ISS modules could have been awesome. 22 ton was more than good enough. It just was tiny. So size was like, as in volume, as in liter capacity was the limiting factor. So we do need space. In space, if you want to cram a lot of people and want to do stuff, you need space for psychological reason, for health reason, and for everything else. You need space. So that's the first thing. You shall have space in space. Second, food. Food is idiotic in ISS, and that's not going to be good. Again, that's what we learned. The Mark 1 project, we are learning with it. Because again, eating like, dehydrated food once in a while, it's okay. Eating that as a daily meal is starting to like, fatigue you. And again, having some pizza and all that, like, it's okay, but like we really need to solve that problem. Like quality food, and I mean quality. Another aspect, washing machines. Somehow we have ISS, we have a Chinese space station, and we had Mir space station, we had Sky, no washing machine inside. Literally all the clothes are keep using it as long as you want. I'm not even joking. There is a company in Germany who's researching how to make sure a cloth does not sweat, as in like your sweat should not make it smelly. I'm like, put a washing machine. It's like, and what happens to current clothes? Once you have wore them, you put them in return capsule, it burns into the atmosphere. So yeah, we have to figure out how to put a washing machine in 0G. Difficult, but not impossible. Another is odor control. Surprisingly, ISS, even with all that good management and all that, air quality was really not that great. But again, Mark 1 product, we have learned from it. And multiple transit craft, this part ISS got right. ISS was designed from day one in such a way that you can have at least minimum of 2 crafts docking. And other designs that are coming online, they are planning for multiple docking. Ideally, you should be able to dock as many things as you need. So multiple docking and basically crafts, ideally multiple vehicles also. And all of those things will give you flexibility, because sometimes if you just want to carry payload, it does not need to come through the pressurized system. And again, you want pressurized system booked for people. So for that reason, orbital reef has some really good design, good space, good volume, and the idea of docking from multiple places. Starship, again, some companies are betting on it and they're designing modules. One module is so big, then it's like, you know what, that's good enough. One module is almost like more than the usable space than ISS. ISS is bigger and heavier, it's just that it does not have usable space. This sort of designs will have much higher usable space. And if it can keep docking, keep building it bigger, awesome things will happen. So that's the second milestone. We must have a lot of space station, and it should be just like, who cares? That's the next step after solving the rocket part. Now we come to the thing, lunar base. Now you have to understand, we have to be ready for moon, and again, we are working on it. And for permanent stay, it's a much different ball game than Apollo 1969. So fundamentally, we have to handle all the challenges that long stay will bring. And we need technology, of course. Thankfully, a lot of the early technology is being tested right now, but we do need testing what we call in situ, meaning you can design a suit. It's like, this is the suit. Suit can handle it. It has flexibility and all that jazz. But here's the deal. You can't simulate zero G or low G environment of moon. So you have to go actually there and figure out how the dust settles, how the heck dust causes issues. So for that reason, we have to actually test it on that. Only then we can select, yeah, this suit actually works. No, this design degrades too quickly. We have to find something more. And you're like, okay, how we did in Apollo. Again, Apollo era was do it, hope for the best, come back. Now, keep doing it. So keep doing it makes it difficult. It's like, making some electronics, like, in home once in a while is one thing. Making mass production is a completely different ballgame. Same thing. And resource extraction and construction. This is the biggest next step that we must take care of. Basically, how we must solve rocket for space, must solve space station for more money, must solve resource extraction and construction in order to actually have a growing base, meaning you drop some parts and you expand from it. Basically, Expanse TV show's opening sequence was awesome for this. It's like they actually showed it. You cannot just have like what Elon Musk smokes, where it's like, we're just going to go to Mars. No, you're going to be dead if you do that. Like, you can go and come back, and that would be a very degrading health-wise experience, but you can't go and stay. We cannot do that. Even with 100 Starship or 10,000 Starship, that cannot. We do not have the technology. And Expanse really showed it. Like, first people jumped into the moon grew, then people jumped into Mars. Again, you will have missions going back and forth. And I have no idea. I wanted to talk with the artist who did that. It's like, why you have yellow lights on moon? Yellow light is a penalty of sodium vapor lamp. That's how old images look. Look in the modern satellite photos. Most are white. So I can guarantee you moon will look white. At least they're artificial lighting. So fundamentally, we have to do that, where we can expand. Basically, we dropped 1,000 people, and then they should slowly multiply and keep growing. Unless we can do that, forget about Mars. Like, don't even think about Mars. Now, that does bring a sad part. That means the likelihood of Elon Musk living long enough where he can see Martian colony. Yeah, Martian human mission, that should be doable. But Martian colony, no. So that's there. And thankfully, testing has been going on, and all the Mars technology that you want to do, again, the best place to test is in moon. So, and I have to say, China has planned about this quite well, and they are finally sending a 3D printer that is using solar light and concentrating it and firing it on a fixed spot, melting it. And like, how can you melt it? Well, on Earth it will not work because we have atmosphere. On moon it will work because there is no basically atmosphere to leach the heat away. So you can, even with solar light, and be mindful, there is no atmosphere. So not only your heat is not going away, the solar flux coming is far more stable. So you can like so you can put some energy into a spot, and then they are supposed to build structures like small blocks, so to say, Lego blocks, and they're supposed to use robotic arms to construct something that is like the but be mindful, that is launched supposed to be launched in 2028, Chang'e 8, I think. So something like that. So that's the next step. And again, we have to do this. If we just go to like, this is the module, we live inside it, yeah, we did. So the idea is, you put the module, you start constructing base around it, meaning as thick as possible regolith base. And again, you can just print the outer line, fill in the area with the lunar soil, and just keep building it. And ideally, we'll reach a point where we can gas tight this sort of structure. Then we can just have a one module of like, a pressurized door, and done. Once we do that, then it will be awesome. So, and it can be done. Theoretically, it can be done, because again, glass is a surprisingly gas-tight medium. And if you have like thick glass, like 2-3 inch thick glasses, yeah, gases are not. And then you have thick 1 or 2 feet or 1 meter maybe thick of lunar, and then another glass, another regular layer. It's gonna last for centuries. So we got this. So, but again, we have to physically do it too. So we got this. So lunar base, first lunar base. You can have Mars missions, but without lunar base, nothing. And most of us should live long enough where a lunar base, quality lunar base should be a thing. Now, all of those things are the steps, but missing links are networking. We do not have networking in space. Like, you would be shocked how horrendous majority of the missions are. Like, we have awesome cameras on lunar landers. It's like, GG, we're gonna land, and rocket's gonna fire plumes, and we're gonna analyze the plume. Awesome. When we're gonna analyze it, rocket landed. Yeah, wait. It's like, okay, how long? No, keep waiting. We have to transfer the data bit by bit. It's so slow. Like, you would be shocked how horrendously slow. And that's 1 light second away. Mars is 20. So, and 20 minutes, not seconds, 20 minutes. So yeah, data pipeline does not exist. And again, China and USA both are trying to solve it. And China has a plan that they're going to have a sort of radio network covering the whole lunar surface. So for their future missions, they do not have to worry about it. So China is tackling it one way, USA is tackling another way, and it has to be solved because it's fun and games to think about it. It's like, dude, we can't transfer data right now. And again, majority of deep space probe, they are not limited by the technology, they are limited by the transfer. They're not limited by technology. Like if we have RTGs, we good, then why don't we do it? It's like we can't transfer the data. Like half of the probes are like, yeah, there is no, why this probe is limited? Yeah, but like we can capture it. We can have 24/7, 4K Ultra HD video coming out of it. It's like, then why don't we? Yeah, we don't have throughput. We can't transmit the data. It's like, we are just hoping the deep space network captures some photons. It's like, it's bad. So one option is laser beam for a carrier medium. Basically, right now the carrier medium is radio wave. We want to go to laser. Now, why is that? Well, if you remember the movie Martian, you must have seen that he was aiming the antenna of the rover to the moon. Basically to Earth, and he was successfully establishing connection. Is that possible? Absolutely. Why? Well, no matter how tight the beam is when it's originating on Mars, by the time it reaches Earth, it will be expanded beyond the diameter of the planet. So it will hit. You just have to aim it close enough, it will hit. So that's the good part. Penalty, it has expanded that much, meaning the actual bits that you are transmitting is slow, super slow. It's like, yeah, you can't have 4K coming in from there. Like quality 4K, no, don't you, like we can send captures, like all the camera equipment's there, that's more than good enough. It's just that we don't have the pipeline. So that's the radio limitation. So NASA is trying to use into laser. Now, what would be the benefit? Primary benefit would be the throughput would increase exponentially, not a little bit, exponentially. Basically, you will go from kilobits per second to megabytes per second. So it would be exponential gain. So that's the first part. And the second is, okay, that's the carrier, that's the physical thing. What about the software stack? Well, they are also developing that, what we call DTN, delay/disruption tolerant network. Right now, TCP, again, TCP was designed for Earth, and UDP, all these things are designed for Earth, meaning they are assuming the link is intact. So they only transmit data when link is fully intact. If something bad happens during the link breaks, kaput, your link fails. Now, DTN is designed so for links to go kaput, because they will have occlusions, meaning you are going on the other side of the planet, you are going through this, or something is actually, moon is coming through the base, or whatever have you or sun. Because again, planets going to go through a point where your sun would be in between. So in those sort of scenario, this protocol will have relay satellites, meaning you will have radio coming from the surface of the Mars going into satellites. So satellites will fire lasers. That lasers will go basically some intermediate satellites, and that satellites will establish link from the next satellite. So ideally 3 or 4 satellites, and they should be able to reach Earth. But here's the deal. What happens when you are occluded? No problem. The satellite will fill up the buffer. They will not fail the link. They will keep filling up the buffer. And once the link is established again, the data will be transmitted. So the throughput with this sort of disruption tolerant network should be high enough where you like, while latency is high, but you should be able like, yeah, here's a 4K movie. So hopefully when this sort of system is implemented, we can actually watch Martian landing in 4K high quality. So that should be possible. And again, early stages of testing has already begun. So we are slowly putting things in place. And again, all of these things were known. We just did not have rockets. Now, once we have rockets, it's like, okay, keep launching it, keep launching it, keep launching it. It's like, why the heck all the companies are getting so many payloads? People were stuck. We were like, if we only had cheap rockets, we have cheap rockets. We just have more than enough payload. Like 10 people are like, we're going to do this. 15 people are like, we're going to do this. 10,000 people are like, we have this. We're done. We sorted. We're good. So networking, we have to solve it. And then we come to the fuel system. So right now our rockets are becoming very good, and by 2035 we should be really good from sea level to orbit. But here's the, once we can actually do refueling in space, in orbit, things will become very good. Basically, we're going to have massive tankers, be it this or something like that, and these massive tanker will take care of swarm. Idea is you're going to have a tanker, and these tankers will basically have a swarm. That swarm of CubeSats that is going to go collect their fuel and propellant, and that's gonna do servicing mission, cleanup mission, all of those things. Like, there is more than enough demand for it. It's like, you build it, people will come. Like, demand is already there. So the idea is you're gonna have that, and these assets can keep working in orbit for years. You can just keep sending one launches every like a few months to keep refueling it, and big ones will refuel one big one once. So, or like, worst case scenario in SpaceX design, refuel 16 17 times, or maybe 25 times for one. But again, that is extreme design, stupid design. But this sort of designs are far more likely to happen, and more than enough people are working their ass off and pouring enough money into it. This, you are more likely to see this just as a thing, like it's just a thing that happens in space. You do not have to worry about it. And another aspect is deep space mission, is that we realize that rocket throwing is not that good. Like, we are going shwee, that's not that good, especially once you are only relying on orbital velocities, aka basically whenever you see we're talking about gravitational assistant, you're not assisted by gravity, you're assisted by orbit. Basically, it would be solar gravitational assistant, because if imagine it this way, this is your fixed frame and this is the planet. You're looking from the pole top down, the thing will come in, it will become faster, it will slow down when it's going. So gravity has no effect on it. Gravity only allows us to steer it. So it's gravitational steering. So how the heck you're getting that delta V? Well, it's also moving. Now lock yourself from sun's point of view, and you will see planet going like this. That velocity is being leached. So it's like a magnet that is like, okay, coming. So magnet is giving you two velocity. It's orbital velocity plus its gravitational. It will take away the gravitational velocity, but it will not take away the orbital velocity. So that's why when you are doing yeet around bigger the planet, and especially if moving very fast in the orbit, whoo, you're gonna get some speed. Now, this is all good and well, but we do not like the idea that, oh, we launched this thing. Okay, when is gonna go to Pluto? Yeah, 10 years from now. Not good enough. We should be able to do Pluto in few months. And again, technically we can do that right now. Right now we can do that. It's just that we have to solve atomic power ion engines. Now, how do we do that? Well, we have two options. First option, RTG, safer, simpler, but low power, but does work. Everything is sorted. RTG is sorted, ion propulsion is sorted. Just attach those two puppy, yeet. So that's the easy option. Second option is NASA's kilowatt reactor, which is 1 kilowatt, 200 kilowatt output. That will move ass. And again, done, tested, sorted. So if we launch that, that can do Pratishtha Chrome burn to Pluto. So not only we're gonna go to Pluto, we're gonna orbit the damn thing, not just like shwee. So that's the awesome thing. And moon will become our fuel depot. Like, wait a minute, why not Earth? Yeah, Earth has a deep well. I'm standing on the deep well. So that is like a 9.8 meter per second. It's deep, like ludicrously deep. It's so deep that it's cheaper energy-wise to literally smelt lunar regolith, make liquid oxygen out of it, put it on a maglev cannon or a spin launch, and just put it in low Earth orbit. That's cheaper energy-wise. So, and again, ideally you would want to do that at some point. It's like, why we have so many people on moon? Do something productive with that. What about fuel? I do not know certainly. There are some people saying we have enough water on moon to do things. Other people saying we do not. But carbon is there. So we have oxygen and carbon. Just missing element is hydrogen. So that's the problematic part. So moon will become a fuel depot for Leo. And once you have that, then we can like really just yeet things into space. And colony needs a lot of stuff that will turbocharge our 3D printing side of things. Because again, we are making some good progress with 3D printing. Meaning 3D printing went from, hopefully it works, to like, no, it works. It's a useful thing. Oh, wait a minute. ISS have few components that are 3D printed. Oh, wait a minute. Astronaut spacesuit has few components that are 3D printed. So we are making good progress, like really good progress. Basically, it's sometimes a good thing for that patent to expire. Once a lot of people start to pour their money into it and brain into it, it's like, oh damn, we can solve this. Oh damn, this can solve this. So the fuel system will really allow us to have our wings spread out. Now, put your comments down below. What do you think will happen more likely? RTG-based ion engines or reactor-based ion engine? So this was my presentation on basically what's next. Now, what's now? We reached a point. This is the zenith at this point in time of achievements of rocket. We have crossed the threshold. More and more rockets will come on in, and more they will become boring, because again, we got this. And what's next? Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.